ago, there was absolutely nothing. Zero space, zero time, zero matter. All that existed was an infinitely dense speck, until it erupted. Look at this 3D model of the event. Notice how the grid itself stretches outward from the center. The Big Bang did not happen inside an empty room. It was an expansion of the room itself. In less time than a fraction of a single second, that speck scaled up to encompass the entire physical universe. At this stage, the environment was a chaotic, superheated soup of pure, volatile energy. That intense heat actually created a physical barrier to creation. The volatility made it completely impossible for even the most basic atomic structures to survive. Notice the direct mechanical relationship between volume and temperature. As physical volume expanded outward, ambient temperatures plummeted. With extreme heat fading, frantic energy slowed enough to lock together, creating the first stable atoms. Once those atoms fully formed, the cosmic fog physically cleared, allowing light to travel freely through the darkness. With mass now present in the universe, a new physical mechanism took control: gravity. It grabbed hold of the tiny amount of weight inside those newly minted atoms. Slowly, it dragged countless billions of these microscopic particles across the void, pooling them into massive gas clouds. Deep inside the cores of those gathering clouds, the immense weight piled up, causing a sharp spike in mechanical pressure and friction. The localized density eventually reached a critical threshold. The intense friction forced the gas to violently ignite into the universe's first stars. These initial stellar ignitions provided the massive gravitational anchors necessary to group surrounding bodies into the very first galaxies. If you look past the bright exterior of those early stars and zoom deep into their cores, you find a brutal environment defined by crushing pressure. In this physics model, we see a process called nucleosynthesis. The massive inward pressure forces simple, lightweight atoms to smash together into larger, denser structures. That continuous crushing process produces a specific output: heavier elements like carbon and iron. But the exact materials required to build complex solid matter are completely trapped inside these impenetrable stellar cores. These early stars operated as mechanical factories, producing the exact ingredients required for all physical complexity in the universe. Eventually, these massive early stars exhausted their fuel supply and collapsed, causing them to detonate outward in enormous supernova explosions. These violent deaths acted as a delivery system, forcefully scattering all that trapped carbon and iron out into empty space. Over time, those roaming clouds of heavy elements cooled down and drifted together, binding under their own gravity to form rocky, solid planets. A solid, life-sustaining planet requires a harsh cosmic trade-off. It only exists as the direct result of a prior star's violent death. Now, look closely at your own biology. Your body relies heavily on the carbon building your cells and the iron pumping through your bloodstream. If you track those exact atoms backward, they lead straight from your veins to the core of a dying star, and all the way back to that expanding soup of energy. You are the current, living result of an unbroken 13.8 billion year chain reaction. You are a moving, breathing piece of that original expanding spark. Hit follow for more cosmic secrets.